Aloha. In this video, we are going to do the binary search tree non-leaf count problem. And so let's take a look at that. And so I've enhanced these last few assignments a little bit and provided you with what actually is, I gave you this information before, but I've actually included it in the assignment itself because it's easy to overlook. And so in this assignment, we're supposed to take the binary search tree class and define a new class named myBST that extends the BST class. And in this particular assignment 9, we're supposed to add a method which will count the number of non-leaf nodes. And so if we actually look at, if you have the textbook, it looks like this. And it's the same problem, and it gives you some examples, and it gives you this URL here. And if you open that, does this work? No. Anyway, this here, this code is exactly this code. And so what this code is this is the BST, the binary search tree class with a bunch of methods in it, a bunch of handy methods for you to be able to do stuff. And then you're supposed to define this myBST class that extends the BST class, and it gives it to you here. It's right here. And then this is code to help you test it. Okay. And all you have to do for this assignment is to fill in this method right here. It's this method which where you get the number of leaves. Okay. And so, you have to kind of understand what this is, and you can do that by reading the textbook, or you can follow along here. And what we're after is the number of non-leaves, okay? But to figure out the non-leaves, it's a lot easier to figure out the number of leaves than it is to figure out the number of non-leaves. So what we do is we figure out the number of leaves, and then we also know what the total number of leaves is. Let's see, that's like this thing here, the size of the tree. That's the total number. I mean, not leaves, nodes. So we take the total number of nodes and we subtract the number of leaves, and we get the number of non-leaves. All right. So to do this problem, okay, and then I gave you a tree here to try out to test your code. It's a little bit different than the one that they give you here, because in the one that they give you in the textbook, it's easy to insert a bug, which this example does not distinguish. So let's get started. So what I'm going to do is I'm going to create a folder right here on my desktop, new, and I'm going to name it, this is assignment 9, right? Assignment 9. New folder, assignment 9. I'm just going to call it assignment 9. All right. And then I'm going to go in and here I am. And so this is where it is. And then I'm going to see, this time I think I'm going to use Visual Studio Code. I think that's what it's called. So I'm going to pull up a command, CMD, enter. And I'm going to CD to this. Let me copy that, and I'm going to CD to paste. And there I am, and then I'm going to type code period. And here I am in Visual Studio Code. And I've already got Python installed, and so I'm going to just create a new file here. Click, and here I am. I'm in this folder, and so let me go back over to here, and let me copy this. Copy down to here. Shift click, copy, paste. All right, and I'm going to call this save as, I don't know, how about something easy for me to type? How about main? Main.py. There we go. Great name. All right. So we have to start typing in right here. We have to type in at 192. Is that close to what it says here? 192. Okay, great. So we have to type something in there, and then this is gonna. Let's take a look at this. Take just a moment. Oh, there's an extension. Okay, let's take a moment. We do this thing. Windows Workspace. And what I'm going to do is I'm going to create this tree right here, this tree. Okay. And here I am, this Windows Workspace. If I do this. Okay. Let's see. So I gotta click here, I think, and click. I'll make this a little more colorful, blue. Let's see. So first I start with a 6. 6. And then a 3 is less than 6, so 3 can go here. And then a 9 is greater than 6, so 9 can go here. 9. And 5 is less than 6 but greater than 3, so 5 can go down here. And 1 is less than 6, less than 3, 1 can go here. And 33 is greater than 6, it's greater than 9, so 33 goes here. And 61 is bigger than 6, bigger than 9, bigger than 33, so it's got to go here. And 63 is down here. And 59 is greater than 6, greater than 9, greater than 33, less than 59 is greater than 33, less than 61, so 59 is here. Okay, so that's what the tree looks like. This is the binary search tree for this 6, 3, 9, 5, 1, 33, 61, 63, 59. All right, great. So this has how many leaves? It's got 1, 2, 3, 4 leaves. And how many? So 4 leaves. And how many non-leaves? It's got 1, 2, 3, 4, 5. 5 non-leaves. Five non-leaves. Okay, so let's look at this code here. Okay, so the task at hand is to write this method right here. And this method has to return the number of leaves in the tree that starts at this root, at this this node right here, which we call root. Okay, now what this method is basically going to return the number of get number of leaves 1 of its left child plus of its right child. So so this when this method is called, it's gonna call itself to find or return the number of leaves in its left child, and it's going to then call and get the number of leaves in its right child, and then it's going to add those two together, and that's what it's going to return. So what's missing here is the termination condition for when this root, the value that is defined as the argument to the method here, which is this. When we are considering the case here, for example, when one of the children is null, or in this case here, when both children are null. Now we are looking at this point with respect to the a node that has 2 children. We're looking at the 2 children. We want to add the number of leaves that are in the left child with the number of leaves that are in the right child. So the first thing we need to add here is if the root is null, which is expressed this way. If the root is none, then there is no tree. There's no node, so there's no tree, so there's no leaves at all. So we return 0. The second case is elif the left child is okay. So the root is not null. The root is there. The node exists, but the left the left child of the root is null, and the right child of the root is null. In that case, we are at a leaf. We're looking at a leaf. So in that case, we want to return 1 because it's one leaf that we're sitting at, okay? Otherwise, we want to, otherwise this node has at least one child, so we want to ask what the number of leaves in the left child is and add to that the number of leaves in the right child. And the number of leaves in the left child is either going to be this, because there is no left child, or it's going to be this, because there is there's a left child, and the left child is a leaf. All right. So this may be all that we need. Let's try this. Let me save this. Save it. We see the squiggly goes away. Why is this there? All right. Okay, so I don't see any squigglies. Let me save this again. And let's try to run this. I'm going to use the terminal. And here we are. We're in assignment 9, so I'm just going to run this py main.py. And it outputs the number of leaves in an empty tree as 0 because it asks, we start out by, we've created a blank binary search tree with no nodes, and we ask what the number of non-leaves is. And then we ask for this for a tree, and let's enter these values. Paste, and it says the number of non-leaves in the tree is 5. Is that right? Yes. 1, 2, 3, 4, 5. Yes. All right. Okay, so it looks like that works. That is the answer, and hope this helps. Thanks for watching.